In the last video, we discussed about the general ideas regarding triggering. And in this video, we're gonna tackle the problem we raised towards the end of the last video. The problem is saying that there are more complex waveforms compared to clean sinusoids, for which it's almost impossible to use a fixed threshold triggering technique to trigger that kind of more complex signal correctly. So on the oscilloscope right now, here shows one example of the family of these more complex signal. This kind of signal is called amplitude modulated waveforms, so shorthanded as AM signals. Yes, you're right. AM is really the AM that you hear from the AM radio station. So it's pretty directly related to our daily life. So let's take a look at this kind of signal, right? Let's zoom in a little bit. Zoom into one period of this signal. Okay, let's zoom in more. Okay, so you can see that because of the fact that if you use a single threshold to do your trigger, it's almost inevitable that wherever you put your trigger level within the range of the signal, you're almost guaranteed that to have multiple crossings of your waveform and the multiple crossings between your waveform and the threshold level. So basically that means you would have many legit time zero reference points for your quote-unquote snapshot taking of your oscilloscope. So let's see what will happen if I just directly use the fixed threshold trigger. Okay, if I set the trigger level to within the range of that AM signal, you see that the picture is jittery. It's really because that there are many legit 0 points basically, so that the picture is very jittery. Then how do we correctly trigger this kind of signal? We might want to use the help from the function generator, which generates the AM signal itself, right? So the function generator has a functionality of generating a square wave together with whatever waveform you're generating, right? That square wave is in sync with your original waveform. What in sync means is that the square wave is always synchronous to your signal. Synchronous meaning that they have the same frequency and the same phase. So I've already hooked up everything so that if I turn on channel 2, you can actually see that sync waveform, which is a square wave, right? Think of it this way. Square wave is actually very easy to be triggered by fixed threshold trigger level. You can put your trigger level anywhere in between the high levels and low levels of your waveform, of your square wave, to correctly trigger that square wave. But here's the thing. You know that the square wave is always synchronous to your original waveform, but your original waveform is very difficult to be triggered with. Why don't you just trigger your sync waveform, which is a square wave? It's very easy to do so, and because the sync square wave is always in sync with your original waveform, if you can trigger that square wave correctly, you indirectly trigger your original waveform correctly, since they're always in sync. So the correct technique to sync, the correct technique to trigger the AM signal is just by triggering indirectly its sync square wave. So now you can see that I put the trigger level anywhere in between the high level and low levels of the square wave, and we get a static picture, right? And of course if I move the trigger level outside the square wave, it's gonna act crazy. And this is what we call the external triggering technique. We use an external signal helping us with triggering the signal we want to measure. So actually we won't be using this kind of technique in our course because in this course we assume that we're always dealing with clean signals that are simple enough, like square wave or sine waves that do not have multiple crossings if you use a fixed threshold triggering. So this is the last time you will see this technique in this course. But do keep in mind when this external triggering could be helpful to you.